Please welcome Michael.
Wow, I can hear that applause. Thank you. All right, talking of newbies, this is me being a newbie on Zoom and presenting remote. I'm going to share my screen. I'm going to choose my whole desktop so you get to see everything. How the hell do I move this? Oh yeah, drag that. So then we bring this up and finally we start presenting our slides, and I'm going to ask, can everyone see my slides? Yes, cool. Arduino on Rails. I'm Michael Milewski. Ceramic is my GitHub and Twitter handle. Feel free to follow me there. All right, let's get started. Arduino on Rails. So some of you probably have heard of Arduino, but you still may be asking, what is Arduino? Arduino is an open source electronic prototyping platform enabling users to create interactive electronic objects. Do you guys follow? Yes or no? I think no. It's a bit of a mouthful. So let's take a quick step back. What would this sound like if I looked up the definition of Rails? Well, what is Rails? It's a web application framework that includes everything needed to create database-backed web applications according to Model View Controller. Now, I'm sure if I didn't know anything about Rails, it would be pretty hard to understand what that meant as well. So I gave it a go myself. What is Rails? Rails is a computer of sorts whose interface are REST endpoints. So the way we kind of talk to this computer, which is backed by a database, is usually through some kind of an endpoint, which we may use a browser for or some other API. So if we squint and hold that thought, what is Arduino? Back to Arduino. Arduino is a computer whose interface is voltages, i.e. electricity, right? So the way the computer talks to other things is literally a piece of wire and it changes the voltage on that. So that's what an Arduino is. What can it do? Well, it can read those voltages as inputs, so it can find out what's coming in. It can set voltages as outputs, and it's a computer at the heart, so it can still perform computations based on those inputs. Let's get into a little bit more details. What could those inputs be? So any analog voltage from 0 to 5 volts could be an input, which means maybe I have a light meter that tells me how light it is, or a temperature sensor to tell me what the temperature is, or maybe I've got a microphone that changes the sound into a voltage between 0 and 5 volts. As inputs, I can also take serial data in. So maybe I have a GPS, a global positioning system that knows my latitude and longitude, and it can write serial data through the voltages to tell me my location, or an RFID reader to tell me the ID of a particular card, or maybe a real-time clock. So these are various inputs. Now, what can an Arduino output to? An Arduino can output a voltage, a digital voltage, either low, which is 0 volts, or high, which is 5 volts. And I can use this to turn on an LED, a light emitting diode, or a relay. I can also do what is known as pulse width modulation, which allows me not only just to turn the LED on, but maybe to dim the LED or play a sound or change the speed of a motor. And just as I could read serial data in, I can send serial data out by driving something like an OLED display or driving a server or some other device. Right, and you've probably thought about that and going, okay, I still don't get it. So Michael, why don't you show me now? I'm going to attempt some video here. Let me just turn this thing on and see if this works. So I presume everyone can see my my camera and a jumble of wires. Is that yes? Yes, there's thumbs up. Excellent. So I said show me. Let's have a look. We're going to look at this. We're also going to look at this. So here I have my desktop with lots of wires and things. I'm going to see if I can focus that a bit better. No, that's as good as it's going to go. And then here I have a terminal. So this terminal is actually connected to this Arduino. So what is an Arduino? Let's have a look at an Arduino. Here I have an Arduino in my hands. There is a USB connector on this side. There is the main chip, that black thing there. There's an LED that's showing that it's got power. And I've got a bit of a circuit here, which is in a prototype kind of fashion. That's basically got a number of elements. One of them is this LED here. Now its video is frozen. This LED here, if I press this big yellow button, that LED is going to flash. So let's do that. And the video is not updating. Oh, there it goes. Okay, so as I said, I've got some technical difficulties here with the video while Zoom is running. But trust me, it's flashing. I suppose I can also show you on the other video. Maybe that's better. Although I don't know if that's then recorded. Is my face video recorded as well, Vanessa? It is. Cool. All right, so maybe that's a better place to see it, which is why actually I rearranged my cameras. So let's get rid of that one. That one. Yes, quit. So I have a flashing LED, right? A flashing light for all intents and purposes. So I've shown you that I can do that by turning a voltage on and off. Let's have a look at what that exactly means. So in here, I have what is the equivalent of the hello world of Arduino, which is to blink an LED. And I can see there's two main methods. The code here is actually C++, although given how small an Arduino is, it's for all intents and purposes, it's like C. And an Arduino has two default methods. One is setup. Setup is called anytime the power is booted, and the other one is loop. And loop is just called forever whilst power is on. So the only thing I'm doing in setup on line 2 is saying, hey, change the pin mode of the LED built in to be an output. And then on line 6, I'm saying turn it high, which is 5 volts. On line 7, I'm saying delay for 200. On line 8, I'm saying turn it low, i.e. turn it off, and then wait another 200 milliseconds. And with that, I get this flashing thing. Now, that's all nice and good, but it's a very simple program. The other thing you'll notice is this is a real-time platform. The only things it can do is line 6, 7, 8, and 9 within that loop. And if you actually look at what's happening, line 6 takes one or two, couple of clock cycles to execute. And then line 7 is waiting the whole time. So if I wanted to interrupt this in some way, there's no easy way. I have to wait for the whole loop to happen before I can interrupt this. In this case, I would have to wait 400 milliseconds. But I've actually kind of done it slightly better than that, and we'll see what was involved. So when I press this button, I only have to press it once, and it's going to move from flashing red to flashing green or blue. There you go, flashing green. So I didn't have to wait for any period of time, because rather than doing this basic approach that is here, let's have a look. We've got an improved version. So if you look in this improved version on line 18, I call out to blink. And on line 19, I have a delay of 20 milliseconds. So that's the only time that I'm really blocked in my loop. Literally every 20 milliseconds, I'm checking if if there's anything else happening. And all in this case, obviously in line 8, I have my blink. And in there, I'm actually calculating based on the last time I've turned this on and off using millis, which is on line 9, which is basically the duration of number of clock cycles since I've turned the Arduino on. So it starts at 0 and just keeps going until it runs out of however big a long is. But obviously you can see just for my program to start to think of being interrupted by other things, I have to do quite a lot of different coding just to do that. Now I'm going to click next. I have no idea what the next slide is. Oh, right, pulse width modulation. So we had this example where we blink, and I'm going to press this again. It's going to blink blue. There you go, blinking blue. But this is just turning things high and low. What I want to do now is I want to fade the picture in and out. So I'm going to press it again. No, oh yeah, there's a big powerful LED, right? There you go. That's how surprising it is. But then if I press that again, we should get a fading. So now that blue LED is fading in and out. So rather than just turning it on and off, it's doing something else. Well, actually not that much different. It's looking back at the slides, it's doing what's known as pulse width modulation, which is turning it on and off very quickly. As we can see at the top left, 0% is basically when it's off. At 25%, the value I can set on my output is between 0 and 255. So around 64 would mean that the this pin is turned on for 25% of the duty cycle. At about halfway point, it's 50-50, 75. And then if I do 255, it's fully on. And if I apply that to that LED, when it's fully on, it means it's always on. When it's completely off, it's not. But when it's 25% on and off, it's flickering, but to the eye, it's flickering quickly enough. I believe at something like 5 megahertz that you can't actually see that it's flickering, and it ends up deceiving you to see that it's faded. So that's the idea of pulse width modulation. Let's have a look at the code. So the code is kind of interesting because I think a lot of people doing Ruby and Rails get away from maths. But here we are kind of all in. We're right down at the layer of the hardware. So it's all into the maths. So I've got this loop. And in that, the first thing I do at line 2 is grab my milliseconds to say, hey, what's the time since the Arduino was powered on? And then because I know I want to fade in and fade out for the maximum of 255, I go and get the modulus of 512, which is double that. I then check, I then offset the modulus by 255. I get the absolute value. And finally on line 6, I write that fade amount to the LED pin. Now that sounds like a lot of complicated maths. Let's have a look what we get here. You can see I'm connected to my Arduino module, and it's actually telling me all of these numbers, which is basically saying what the numbers are being calculated every 20 milliseconds or thereabouts. But there is another option here. Rather than doing a text mode, I can change there's a tool in the Arduino kind of IDE to say, look at a serial plotter. And when we turn the serial plotter on, and I'm gonna, unfortunately that resets it, so I'm gonna have to get back to this. We're now seeing these plots happen, and that's that maths I was showing you. So if 0 is 0, that's this line here. The top of these blue peaks happens to be sitting at 512. So what we can see is as time goes on, the blue wave goes from 0 to 512. Once it peaks out 512, it resets the counter and basically just creates this sawtooth pattern, which was that first part that we were doing. The next bit, I took 255 away from it, which became this red pattern, which was going up to 255, down to minus 255, and up again. And finally, I was getting the absolute value, which was flipping the bottom of this red into the green. So the green shows us what the LED is doing, which if I look at the camera, should be in line with the camera. As the green goes to the top, it gets brighter. As it goes to the bottom, it gets less bright, and so on forever and ever. So that's the way some of that maths kind of plays out, and some of the tooling you have when you're playing with Arduino. So that's a pulse. Let's see what's next. You can have a tune. Let's see how this works. So I have a speaker here. I have my microphone here, and let's see, we'll see if anyone can hear it. All right, yell out if you know what the tune is.
Inspector Gadget.
Inspector Gadget.
Yeah, Inspector Gadget. I played it for my kids. They said, what? No idea. Anyway, so that was Inspector Gadget. The general idea behind playing a tune is what you can see here. In this case, on line 2, I am playing a tone. The tone basically plays a pulse width modulation to the pin, in this case, a speaker pin. The second argument is 440, which is the frequency, which is a concert tuning A. The 1000 is how many milliseconds to play it for, and then you can put a delay in between your notes, or you can turn the speaker. You can create no tone on the speaker pin as well, and you know there's a few helpers out there to allow you to actually play tunes, but you're still basically kind of down at that level. So you can do this as an output. You can also do inputs. One of them is temperature. So to do that, I'm going to jump back in here. I'm going to kill that and bring in the serial monitor because it doesn't plot that well in this case. What you can see here in my camera is a chip that looks a little bit like a transistor. It's actually a temperature sensor. I'm going to go into temperature sensor mode, which is not there, not at the music, but here. So at the moment, if I clear the output, it's telling us it's 21.71 degrees Celsius. If I put my fingers on that, it starts to go up, 24 degrees, thereabouts, fluctuating a little bit. And if I put my cold fizzy water next to it, hopefully it will go down slowly. Well, not that slow because my finger's on it. Oh yeah, it's going down as well. So you can connect various sensors to it. That was one of them. That's temperature. And obviously you can do a button, which I showed you, that yellow button, which takes us through various examples I've shown you. Again, line 2 is called only on power up, which says pin mode for 2 is an input pull up. Now this is interesting. One of the things about working with voltages is Ohm's law. And one of the killers is current. So if you have too much current, you can weld things together, assuming you've got something strong enough to do that. One of the things that you could do is you could connect ground, which is 0 volts to 5 volts. If you have Ohm's law suggesting if you do that with a wire or a switch, if you do that, you will actually have infinite amount of current. So we'll try and run all the possible current through that connection as possible. And you could actually damage your chip, your Arduino or what have you. To stop that, you want some resistance in there. So the resistance reduces that. In this case, there is inbuilt resistance. So you can really simplify your circuit. So the circuit I've got literally just has a button. It doesn't even have a resistor. It doesn't need that. So that's one thing that's happening here. There's an internal pull-up resistor just to make the platform easier to get stuff going. The other thing is, as you can see, if I do this in a loop, I may be doing other things. Well, I may need to read what the sensor is reading, so to say my digital read, and then depending if it's high or off, I may be able to switch things on and off. But again, if that was in the loop, I'd have to wait for everything else in the loop to happen, which is not what you generally want to do. So in this case, there's actually two things you want to do. One, you want to run this by an interrupt. So line 8 here is showing you that you can attach an interrupt, which means that exactly what it sounds like. Rather than waiting for your loop to get to your point in code, which is to check whether your switch is on or off, there's an interrupt, and a standard Arduino has one of these on pin 2. And it means when there's any change, as it says here, any change, it will call the change method, which is on line 11. The other thing is debounce. I'm not going to go into debounce, but basically when you press an electrical switch, it could jiggle around, and rather than touching itself once, it could touch multiple times. So you want to deal with that to make sure it only presses it once for every hit. And then finally, you can do other output things. So we've seen light, we've seen sound. You can also do motion. In this case, I'll have a servo, and the servo is going to sweep. So let's have a look what a servo even is. Looking at my camera, there's a there is a black box which has a motor and some gears in it, and this wiper. And when I go into the servo mode, that wiper is going to wipe side to side. So obviously I have control of how much I want to wipe that side to side. In this case, I'm going quite a bit side to side. And again, the calculation here you get into some heavy maths, potentially, especially if you want to be precise. In this case, I'm doing all sorts of stuff, but again, we can see the numbers, which probably don't mean much. What we can do is get into that mode where we have the plotter again. And if I get back to what that was, which is after the sound, after the temperature, as you can see, what's being plotted now is what is actually being sent to that servo. So that servo is saying jump between 70 and 170 degrees in a sinusoidal fashion. And that's what it's doing, just as a simple kind of demonstration of what can be done there. I'm going to press that to stop that. So we've seen various inputs and outputs. What else can an Arduino do? Well, as I mentioned, it's real time, which means it's not like a computer which tends to wait around and maybe have other processors doing stuff. Everything happens in that loop. You could use one for something like keyboard to make yourself a custom keyboard to capture every keystroke, because it's real time. It can immediately receive any keystroke it can get from a keyboard, but you can't do that if you were just running with a normal kind of computer, because a normal computer may be doing other things in the background. One thing I didn't really cover off, it's got a whole heap of timers for precise timing. We basically mentioned a little bit about interrupts. It can do a number of different serial communications between I2C one wire, SPI, UART or UART. It can talk to a USB interface, and you'd end up doing a lot of bit manipulation. I've put these in there because once you've got across all of those, I think you're basically across everything an Arduino can do. So that kind of gives you the scope of the platform. Obviously, there's a whole heap of mechanical and electrical things you'd have to get going to get stuff to do whatever it needs to do that you want it to do. There's also a lot of flavors of Arduino. I've shown you kind of a standard Arduino Uno, but there's a more powerful Arduino Duo, which has got more inputs and outputs, a bit faster. And there's a whole heap of other Leonardos and Leo sticks and Pro Minis and many cheap imitations you can get. So there's various flavors of Arduino. Interestingly, there is also very popular ESP32 and 8266, and they are popular because they have Wi-Fi and Bluetooth built in. The Arduino I showed you does not. It literally can talk serial to my computer to show me those graphs and can turn things on and off, but it doesn't stand alone. There are other things like the Adafruit Phoner, which has a built-in GSM. The benefit of that is you don't even need Wi-Fi. You literally need a small little board with a SIM inside it, and you can talk across the phone network. There's Arduino Nano 33 BLE Sense, which actually allows you to do machine learning. The kind of extent of machine learning here would be something like picking up the sound from a microphone and learning a wake-up words like "Hello Google" or whatever you want. The machine learning on these can also pick up an image from a camera and identify somebody. There's various other flavors. There's also lots of things that are not Arduinos. Obviously Raspberry Pis, but microbits. There's the actual chips and various other things out there. And why is that important? Well, if you asked me, I kind of got into electronics in the 80s when I was a kid, and kind of in the 90s, electronics died away and was kind of really, there was not much you could do. But then I think there's been a massive rebirth with this idea of these microcontrollers where you can now have devices, internet connected, the whole IoT kind of sense of things. And you can build this stuff relatively cheaply. You can play with it at home. Right, but the question on everyone's lips probably is, what about Arduino on Rails? Have I succeeded? No, clearly not. And how the hell am I going to get Arduino on Rails when Rails is in Ruby and Arduino is C++ and only has 32 kilobytes to have a program on there? Well, I have some attempts. I did try and get Arduino on Rails. Let's have a look. Whoops. Hang on. Let's go back. Here's my one attempt of Arduino on Rails. No trains were harmed in this. in this video. I don't know how legal that is. Right, so I did mention there was this thing called an ESP32, which has Wi-Fi. So I thought, okay, well, if I have Wi-Fi, why don't I connect that to something else? So what I've got here is exactly that video. You have this chip here, which is an ESP32. This is the battery. It's connected to this, and it's outputting some serial data onto this counter. And the counter is telling me how many hits I have on a website. So let me post the link to the website. In fact, if I post, I'll post the link to all the things. The link is bit.ly Roro October 2020. If I find, how the hell do I find chat? Oh, chats. Where is chat?
I can post it if you like.
Chat. I got it. All right. So if you go to that link, it's going to take you here. And it's going to give you the presentation. And the key is you go to this Heroku app, and that's going to increase the counter faster than this is increasing it. This is increasing it every time I visit it. So it goes up 1, 95, 98. So yeah, every time this goes up by more than 1, that means somebody else has hit that page. And you can have a look at the counters. So obviously the counters are in here, 3,000 already and 52. We'll have a look at what the code is for that in a second. More importantly, you can also subscribe to my YouTube channel where I don't have any YouTube videos, but if I can get to 20 subscribers by the end of today, I promise I will post a first YouTube. We only got 5 subscribers. If I get to 20 by the end of today, I will post you a video on this weekend, after the long weekend. I'm sure I can do it. So what's going on here? Well, I thought I'll create a basic Rails app. So I did a Rails generate counter with a name and a string. This is where this presentation software falls apart because I can't see the bottom of it. Let me just move this off. All right, what I can do is look at the slides in here. Don't use bad presentation software is what I'll tell you not to do. So in here, we have what we're looking at here, which is this. I presume you can see my GitHub right now. So in here, I generated a counter with a string. I created a basic Rails model with an increment default counter method, which would find or create the counter that you saw being shown. And then just to make it always hit, I created some middleware. So here's a middleware. And the way middleware works is you kind of configure it in your application to say, hey, use this middleware click counter. And then every single call goes through that piece of middleware. And it works out if it's a normal call. It adds a header, an X request count header. And it also, in this case, every time it renders a page that is text HTML, it's going to put the counter at the top. So basically this call and this each block gets called every single time you visit that page. So let's have a quick look. If I go to here and I see this page, yeah, you're on Rails. If I inspect that page, we'll see there's a counter. Let's embiggen that. Elements, I made it too big. There's a counter there, 33562, which gets injected. If I refresh 33871, obviously hits are happening all the time. So that's updating it there. And also, if I look at my network tab, we will see that every time I fetch that, there's a header. And in those headers, I should also see my custom header, which is here, the X request count header, which is just a made up header. But I kind of thought, yeah, why not? Let's do it through middleware. Very simple. The code is on the GitHub repo if you'd like to see how it works. So that's kind of the Rails side of that. as discussed, that's the middleware. And by looking there, we all saw the counters update. What do you have to do in Arduino? Actually, quite a fair bit. One, just to get connected with this ESP32, I need 4 different libraries. I need a Wi-Fi, a HTTP client, a Wi-Fi client secure, and to read JSON, as you presume, I need JSON as well. One interesting thing, I'm not going to go into the code, it is there. One interesting thing that you actually need, though, because you're making HTTPS connection and you don't have a browser, and a browser comes pre-configured with certificate authorities for all the root certificate authorities that you could imagine. The Arduino doesn't have that. So I actually have to go and find the appropriate security authority, in this case, the one for Heroku, which comes from DigiCert, and find the exact version of that and put the that certificate into my Arduino sketch, which I upload so that when it does the HTTPS connection, it actually knows that it's secure. All right. So as I said, there's a bunch of Wi-Fi connections, JSON parsing code. We've seen the counter in action, but I promised Arduino on Rails. Have I delivered? No. Still no. Well, that's a shame because I kind of ran out of ideas, of time to get my ideas out there. What I was thinking though is, well, I've kind of cheated because I've got an Arduino with Wi-Fi, which is not an Arduino, but it's an ESP32. But maybe if I took the same middleware approach, I could actually, from a Rails development server, reach out through my serial port to an Arduino and actually have that connection go through the Arduino to say, yep, this request is valid. And I suppose the idea was that I could get to the level where I'd cut a wire, and by cutting that wire, I would actually stop Rails requests, at which stage I'd be happy that I got there. I think it's possible. I haven't got there yet. Maybe next time. And is this just a toy? Have I just given you toy examples? And the answer is yes. Yes, I have, which is a shame because it's kind of like, it's cool technology, but yes. Okay, Grace. But what can you do with it? So one thing I have been playing with at work is 100% yes. Grace, go away. Is what I call cloud scale. And the idea of cloud scale is that would it be possible to have a scale for weighing things? So I work for Fresho, which is a company that does fresh food delivery. And one of the things we do is we create orders, or restaurants buy from wholesale providers, and they may say, hey, I want 20 kilograms of some particular meat. They order it as 20 kilograms, but when it's actually sent out, it has to be weighed. So the idea I had was, well, could we have a real-time scale that actually goes through the cloud and integrates with the website, not through serial ports, not anything else. So the idea there was that you could have a scale that would publish through AWS IoT Cloud. Then a website could use that data and you could have real-time updates. I do have a demo. It's not working this time, maybe next time. So sorry if I couldn't deliver. That is the end of my presentation. But what are the next steps? Well, I encourage all of you to get into Arduino. A cheap kit is about $20, which will give you the Arduino and about 25 various sensors. Go and follow me on, subscribe to my video channel on YouTube, and I promise I will try and post some videos of me doing some of this stuff. And then finally, join me. There's an electronic wings contest, which is to submit a hardware project by the 15th of December. If you're interested, if you've got some ideas, come and join me. Let's see what we can come up with. Thank you. As I said, I am Ceramic on GitHub, Twitter, slides, links, and everything through bit.ly, Roro. And final reveal. Let's see if I do a video today or not. We had 5 subscribers. And we now have 13. Yes, I don't have to do a video this weekend, but if you do subscribe before long, maybe I'll change my mind. That's it. Thank you.
Thank you very much, Michael. That was super cool. I suspect that people might have questions, so might just leave, if you want to leave your screen up and folks can fire away.
Oh, well, just to prompt some questions, maybe. I also did this, and I saw Celia wearing her great T-shirt. So I've got this output, and I've configured it to, amongst other things, do all the Ruby logos, Rails and Roro and everything else on a little screen. That actually uses half the memory on the Arduino, which is kind of a little bit ridiculous, but it's cool. It's cool. I'll tell you one thing, making it one LED flash is 1,000 times more exciting than making your whole screen, millions of LEDs turn on and off in your screen.
Did you use any compression to put those images on there?
No, I didn't. That's actually interesting. Probably you could. As it was actually quite hard to work out how to do that. And ultimately you literally have to write the bits directly there. It's 128 by 64. So I'm kind of curious. You probably could do some compression for sure. But I didn't. If I can prompt another thing you might be wondering, like why Arduino? As a Ruby developer, I think one of the cool things is by trying different technologies, you become a better developer in your day-to-day, right? So at the moment, I'm learning Rust and I'm learning a bit of Arduino, and it's phenomenal just seeing that other community, seeing other approaches, seeing different problems, how much better you become a programmer and solving problems in your day-to-day stuff, which for me is Ruby on Rails and JavaScript. But it's been a great journey learning these things. So I do encourage people to give things a go. As I said, it doesn't have to be hardware, but it could be something like another computer language or what have you.
When you were
getting
it to, oh, sorry.
No, go ahead.
When you were getting it to play a melody, like what's the process behind it? Because I get the whole LED turning on and off, but that it plays a specific tune. Is that like a more advanced, function maybe, or can you change the tunes that it plays, or is it just Inspector Gadget and that's all that it can do? No.
So you're programming that down to the T. So let's have if we quickly, I think I'm still sharing my screen, I presume, yeah? So if we look at the top here, go back to my presentation, and in here, there is the IO demo, where I have the tunes. So let's have a look at the tunes. The tunes are literally written out note by note, like this. So in this case, I know this is the Inspector Gadget tune, Pirates of the Caribbean down here. So I have every note written out. Not only that, I have every duration written out. And then these notes come from a file that somebody else has put together of pitches, which is every note on the, let's imagine on the piano and its pitch. So whilst I have that data, then in my Arduino sketch, I can do anything, right? So I can then, in this case, I just have a loop somewhere in here to basically play one of those two tunes. And it just goes through each one of those notes. But if I wanted an input to change that tune, so if I said, right, depending on how bright it is, I want it to go faster or slower, or change the pitch higher or lower, I could easily do that. So I have full control. So it's not just one thing that I've got. I've got anything I want to do. There is a lot of people that do get into music making with Arduino. If you want to make like a custom drum machine or a sequencer or an old style kind of, what are they called, synthesizers. You can do all of those things with this. I suppose, I mean, the beauty of Arduino is it's like Ruby on Rails versus C. So in Ruby on Rails, you kind of can cut and paste lots of code, and all of a sudden you have magical forms and things just working. Arduino is the same. You don't need to know that much of the core electronics. You can kind of just add a lot of things are literally plugged together and just send some serial data and find somebody's code snippet. So you can do all sorts of things.
It's almost like putting those like old ringtones on your Nokia phone, like, 10, 15 years ago. They just literally went by tune and came up with a new ringtone.
Yeah, you can. But there are, as I said, I mean, there are actual more musical things where you can access MIDI soundboards, which is an external unit, but then you're controlling MIDI sounds, which are just like a normal, you could make a piano, right? With your own little custom bit of coding as well.
Michael, I've got a handful of questions here. You don't mind me throwing them all at you?
Go for it.
Essentially. So you mentioned Rust at one point. Is it possible to actually do the actual coding in Rust rather than C++?
So if I understand correctly, can you? I think you can. There is a library to allow you to do a lot of the coding in Rust. The problem with that is, one, it's harder to get everything going. Two, the library that I mentioned is not fully complete, so it doesn't support everything. And then the tool chain becomes a little bit more complicated because you're writing Rust code, which gets compiled down into whatever it gets compiled into. At that stage, I'm not even sure whether it's actual Rust that you're uploading or whether you're basically just compiling down to C. I've found with a lot of these things, as much as I love the complicated way of like, hey, I'll use Rust or something else, I've tended to also just be pragmatic. And I think for something like Arduino, there's so little benefit to be gotten from doing other things. You're literally just doing it one clever thing, and that's it. And for that, I would say just learn C++ or enough of it to get by. But yes, there are projects out there that do, as you said, Rust. There are boards out there that allow you to do, image recognition. One of the things I've recently bought is a book on TinyML, which allows you to do machine learning. So you actually build a model in a Jupyter notebook, you train it there using Python. The Python then spits out bytecode, which is some kind of C interpreted bytecode. And then there's a TensorFlow library in C that will read that and apply the machine learning on your Arduino. At which stage I'm going like, I don't care whether it's Rust or whatever. I'm just like, okay, I'll use whatever flavor comes with the machine.
Very cool. So okay, so it's a work in progress, the Rust side of things. One of the other things that occurred to me when you talk about the Rails side of things, mRuby can't run Rails, but you could potentially maybe run a subset of Ruby on the Arduino. Is it small enough to run, or you don't know enough about it?
I don't know enough about it. I would say at that point in time, I mean, you can move to a bigger platform like a Raspberry Pi, which isn't even that much bigger, but it's uses a little bit more power. And at that point in time, you have a whole Linux operating system, so you can do anything. So yeah, I mean, I don't know. I'm sure somebody would get excited about running some version of Ruby on a piece of hardware. I know JavaScript has got a stronger kind of following in this, and I kind of, if anyone ever asks me what language to learn, I'd always say JavaScript, because you can use it on the back end, front end. You can use it. I think there is now a TensorFlow JS, so you can use it for machine learning, and you can use it on hardware. And in fact, I think I have some. I went to a Rails camp, Camp JS, I think, and they gave away these things, which are, for all intents and purposes, an ESP32. But if you look at the back, it's actually a Node MCU, which is basically, this runs some version of JavaScript. So as much as we love Ruby, I don't think it gets as much kind of attention in that space. So I know there are certain devices that will run embedded Python, embedded JavaScript, obviously C, C++, and Java, but I don't think anyone's gone out of their way to put Ruby on anything, which means you end up running the C underneath Ruby anyway.
Cool. Okay. Final question. You mentioned the serial interfaces, the variety of different methods, but if you're doing the breadboarding stuff, that you look like you had kitting out different bits of electronics and everything, that's just doing it to CMOS standards?
Well, it depends which ones, right? So the thing I was hoping to get going, this is a breathalyzer, right? Because then I could have, but I'm just drinking mineral water today. So this uses a particular type of serial interface, which is not, I mean, the standard that my understanding is the standard to your through USB is like a TTL 5-volt UART standard, which is that you have a send and receive line, you have power and high and low. With most of these devices, you're trying not to use too many pins, so you're not doing parallel lots of pins. You're just trying to send as much information down one wire as possible. Hence, there is the one wire standard, which literally sends, my understanding is it sends just on one wire, sends highs and lows in such a way that the other device can work out the clock and the data you're sending, and in such a way that both devices don't send on the same wire at the same time. It basically comes down to the device. But yeah, there seem to be a lot of them use this SPI, which is kind of like a 2-wire send and receive plus a ground and a voltage up. And that's for most of your things like this, this thing here. I mean, you can see quite a number of wires, but not all of them are necessary per se, but it's basically sending 2 wires and a whole heap of serial input.
Cool. Okay, thank you.
Oh, I've got one more demo. Are we good for one more demo? I forgot because it wasn't in my slideshow. So if I point down, as long as we, right. Okay, let's have a look. So I press this, we're in flashing mode. Right, because the whole idea in the end is actually to make, where's my camera? There. Sorry, you can see. Okay, so the whole idea is to have interactive stuff. So in this case, I'll go through all my demos. We go, right, we've got the moving thing, and then next one is temperature, I believe. And then the last one will be, all right, it's not going to work. That's great. Hang on. Oh, there you go. So this is now measuring distance from my hand, and that 8x8 board is trying to show how many centimeters it is. So let's put something more solid there. So that is, we can see it 4, 5, 6, 7, 8. So that's kind of ultimately where you want to get to. You want some kind of input that does some kind of output. And in this case, it's also moving out servo. So it's kind of changing stuff. I thought I'd show that because that's kind of like, I suppose, beyond the toy level. Rather than just turning a light on, you actually are interacting with the real world. Again, all those demos are on GitHub if anyone wants to look at it. Or come and ping me on Twitter or email. Let's go and build something together. It'd be awesome.